Hello guys, here is another question from IIT JAM 2017 algebra. This question was requested by Paulami Karmakar. The question is as follows. Where we are given G is a group of order 20 in which the conjugacy classes have sizes 1, 4, 5, 5, 5. Then we are asked to find which of the following are true. Option A is G contains a normal subgroup of order 5. Option B, G contains a non-normal subgroup of order 5. Option C, G contains a subgroup of order 10. And option D is G contains a normal subgroup of order 4. Okay, here in this problem we use Silo theorem. So the class equation is given as follows. And let N5 denote the number of Silo 5 subgroup of G, then by Silo's third theorem, N5 is congruent to 1 mod 5 and N5 divides 20 equals to 2 square into 5, so N5 divides this 2 square. So the choice for N5 is 1, 2, 4, but here 2 and 4 doesn't satisfy this congruence relation, so the only solution is N5 equal to 1. So implies G contains a unique Silo 5 subgroup, and we have some theorem that a Silo P subgroup is unique if and only if it is normal. Implies Silo P 5 subgroup, first suppose let's its name be K, then K is a normal subgroup of order. Silo P subgroup का order is 5. So G contains a normal subgroup of order 5. This one is correct. So definitely this one is wrong. And for the next part, here it is option A. B is wrong. For option C, similarly, G contains an element X of order 2 by Cauchy theorem. For every prime P dividing order of G, G contains an element of order P. Okay. So we consider H to be the subgroup generated by X, implies cardinality of H equals to order of X, which is equal to 2. So H is order 2. Now H is subgroup of G and K is normal in G, implies HK is subgroup of G, which is easy to prove. I leave it as an exercise. So we have HK is a subgroup of G. Moreover, H and K are both subgroups, so H intersection K is also in subgroup, and the cardinality of H intersection K divides cardinality of H and cardinality of K, implies cardinality of H intersection K divides GCD of H and K, which is nothing but 2, 5 equal to 1, which implies that cardinality of H intersection K equal to 1. Therefore H intersection K is trivial. this in turn implies, here we can talk about the cardinality of HK. Here HK is a subgroup by this is by some standard theorem of algebra is cardinality of H is 2, it is 5, it is 1, so there is 10. So HK is a subgroup which is cardinality 10. So HK subgroup of G and cardinality of HK equal to 10. So this shows that option C is also correct. Now we come to option D. If possible, let G has a normal subgroup T of order 4. Now we again have some theorem which is very much important. If every silo subgroup of G is a normal subgroup, then capital G is isomorphic to the direct product of its silo subgroups, and here K is so G has a normal subgroup T which is a silo 2 subgroup which is normal, and again it has a silo 5 subgroup which is also normal. So we name it as T and we name it as K. So G is the direct sum of K and T. Now K is isomorphic to Z5. Since K has order 5, so it must be isomorphic to Z5, that is cyclic group of order 5, and T has order 4, and we know that after isomorphism there are only two groups of order 4. One is the cyclic group of order 4 and another one is our Kleins 4 group, that is Z2 reacts some Z2. So we have only two possibility for G. So G equal to K cross T, which is isomorphic to Z5 cross direct sum Z4, which is in turn isomorphic to Z20, or G equal to K cross T, which is isomorphic to Z5 direct sum Z2 direct sum Z2, and which is again isomorphic to Z10 direct sum Z2. So we have only two possibility for G, and each of them is isomorphic. Each of them is abelian. Here Z20 is obviously abelian, cyclic group of order 20, and here each of Z10 and Z2 is abelians. So therefore their direct product is also abelian. So G implies G is abelian, and we know that, and for an abelian group of order 20 the class equation looks like this 20 times, but here it is not the case because here we have 4, 5, 5, 10. So this is not the case. So G is not in general abelian, so that option D is false. Okay, so here we next move to our next question, which was also asked in IIT JAM 2017. The question is as follows: for x greater than 0, we are given the box function or greatest integer function. We are asked to find the limit of this, find the as x goes to 0. So first of all, what is box function? You know, box of 1.5 is 1, box of 0.2 is 0, and box of minus 0.1 is minus 1, and so on. We all know that. So here we need to find the value. So the property of box function is that box x equals to x minus fractional part of x. For suppose here it is 1.5 minus 0.5. Here 0.5 is our fractional part, and here it is 0. Here it is 0 minus 0.2. Sorry, I think I am missing something. Sorry, here it is 0.2 minus 0.2, because x are here x is our 0.2 and fractional part is also 0.2. So and so on. Where fractional part lies in 0 to 1. So what we do is that box of 1 by x plus box of 2 by x up to box of 10 by x equal to 1 by x minus fractional part of 1 by x, 2 by x minus fractional part of 2 by x, and it so on. It is 10 by x minus fractional part of 10 by x, and if we club them together, it will be 1 by x plus 2 by x up to 10 by x minus fractional part of 1 by x 10 by x. Here it is 10 into 11 by 2 x minus k, where k is each of 1 by x is 0, in between 0 and 1, and 2 by x is in between 0 and 1, and so on up to 10 by x. So if we add them together, we get that k, we take it as k, so we have that k is in between 0 to 10, that is k is something bounded. So limit x goes to 0 plus x into 1 by x, 2 by x up to 10 by x is nothing but limit x into 0 plus x into 55 by x minus k, which is 55 minus kx, and since k is bounded and x goes to 0, this limit goes to 0, so the answer is 55. So our required answer is 55. So if you guys if you guys like our videos, please like and share the videos among your friends and subscribe to our channels. Thank you.